I'd like to talk now about the programming process as it pertains to the C language. By the programming process, I mean what you, as the programmer, must do in order to get a working program. The first step is coding. This is probably the hardest part. You must write the code. You must know the programming language, know the techniques, have designed a program, or at least have someone design the program for you, and then write the code. Next, you must compile the code. You must take the source code that you've written, run it through a compiler. The compiler will produce for you a program. We'll talk more about this in a later chapter. We'll have a full understanding of what compiling is all about. But for now, suffices to say that compiling is the process of turning something that you can understand, in other words source code, into something that the computer can understand, in other words machine code. It's the conversion process. You'll end up then with a program that you can then test and see if it works. That's the third step, testing, which involves running the program and putting it through its paces to see if it does what you think it's going to do. And if it doesn't, that's known as a bug. You've written a bug. A bug is simply behavior of a program that you, the programmer, were not expecting, or didn't code for, or thought you coded for and got it wrong. And the process known as debugging is simply repeating the above three steps. It's going back to the source code, identifying what was wrong, recoding, recompiling, and retesting, and repeating those processes until you believe you've got it right, at which point you give it to the person who's going to use the program, such as your customer, and then they run the program. And guess what? They find a whole bunch more bugs and you go back to step one again. That's the process. Now, we also need to have a quick discussion about how you do this. When I say how you do this, what I really mean is what tools do you use to do this? You have the option of using many commercial compilers out there on the market, or perhaps free compilers, depends on the operating system that you're using. And those tools that you have available to you tend to fall into one of the following two categories. First is the Integrated Development Environment, commonly known as the IDE. And this is a program, usually a single program, where the editing window, in other words the editor that you use to write the source code, and the compiler, and usually even a debugger, are all part of the same program. As it says in the name, it's an integrated environment. You can do everything without leaving the single program. That's very common in the Windows world. Now, in the Unix world, for example, they typically use command line tools. These are a collection of smaller tools, each that serves a distinct purpose. And you'll get a command prompt, such as a C prompt if you're using DOS, but perhaps a dollar prompt if you're using Unix. And you'd type in the names of the commands that you wish to perform the specific task you were trying to use, such as an editor. You'd type in the name of the editor. The editor would start, you'd do all the editing that you needed to do, then you close the editor, then you type the next command, which would be probably the compiler, to compile the source code that you've just written, and so on and so on. If that didn't work, then you would probably type in the name of the program that you just compiled to try and test it, and then you'd probably type in the name of the debugger to try and figure out what went wrong. And then you go back and type in the name of the editor again, and around and around and around you go. Clearly it's simpler to use an integrated development environment, but it's often more powerful to use separate command line tools. For the purposes of this course, we'll be using it in our Windows environment, and we will be using an IDE, and you'll learn about which one in a moment.